Hello everyone, class 12th topic is reactions based on acidic nature of alcohol. In previous videos, we have understood acidic behavior of alcohol. Now those reactions in which alcohol is showing acidic nature, let's check. The reactions are, first reaction with carboxylic acid. Second reaction with acid chlorides. Third reaction with acid anhydrides. And fourth reactions with metals. In all these reactions, alcohol is showing acidic nature. Let's start with carboxylic acid. Reaction of alcohol and carboxylic acid in the presence of catalyst. Yes, these reactions will happen in the presence of catalyst. Which catalyst? Sulfuric acid or HCl you can use. When alcohol reacts with carboxylic acid in the presence of H2SO4 or HCl, they create ester with the elimination of water. This reaction is known as esterification. Already we have done it in a 10th class also. Esterification reaction, because ester is generated. And note down, if this reaction is carrying out in the presence of HCl, so it will become a named reaction which we call Fischer-Spear esterification. Note it down. If the reaction is being carried out in the presence of HCl, it will become a name esterification which is known as Fischer-Spear esterification. Now, H2O is a byproduct. It is important to remove it out. Otherwise, the reaction will start moving in backward direction. So to create more ester, time to time release of H2O is important. For that, we use an apparatus which is known as Dean and Stark apparatus. Beyond the level of 12th class, so we will not discuss it. Now, this reaction, I am going to write in general fashion. ROH general formula of alcohol, carboxylic acid general formula RCOH in the presence of sulfuric acid. So what will happen? H from alcohol side and OH from carboxylic acid. They will make H2O and they will get separate out as a H2O. Now this oxygen will combine with this carbon in this fashion, and you can check this is the functional group of ester. And if you are using HCl, not H2SO4, the name reaction it will become, which we call Fischer-Spear esterification. Now let's check the mechanism of this reaction. Mechanism. This reaction is happening in 3 steps. Step number 1. The sulfuric acid that we are using, sulfuric acid or HCl, we know they will provide us H positive ions. These H positive ions are electrophiles because H positive ion means hydrogen without electron. So vacant orbital is there. In this vacant orbital, it have a tendency to gain electrons. So it is looking for electrons. That's why we are calling it electrophile. Who can provide electrons to it? Carboxylic acid. Why carboxylic acid? Because pi electrons are available. Pi electrons are always easy target for electrophile because pi electrons are perpendicular to the molecule. That's why electrophile can easily attack on them. These pi electrons are more toward oxygen because oxygen is more electronegative than carbon. That's why oxygen is carrying partial negative, carbon is partially positive. So that's it. This H will start attacking on oxygen. For bond formation, we require 2 electrons. Hydrogen do not have electron. So this oxygen will bring both pi electrons toward itself and it will use them to make bond with hydrogen. In this condition, a new molecule will generate. Let's write it here. Pi electrons will shift. On oxygen, hydrogen will attack and bond will generate. Now this carbon is losing its electron. So around this carbon, vacant orbital will generate like this and +1 charge, carbocation. Here we have a generation of carbocation. So in first step, the carboxylic molecule will turns to carbocation due to the attack of H positive ion which were delivered from acids. Second step, the carbocation which is generated, this one, it is also an electrophile looking for the electrons. Who can provide electrons? Alcohol molecules. Why? Because in alcohol molecule, oxygen is available with a lone pair, and oxygen, due to higher electronegativity, carrying a negative charge. So these lone pairs are easily donatable by oxygen. So oxygen will donate one pair to carbon, and which bond it will make? Dative bond. Due to which, okay, note down the hybridization of carbon is sp2 here. So this molecule is triangular. After this attack, around carbon, let's make dative bond through this oxygen. This will be. Now because this oxygen is using one electron toward carbon side, check, two electrons were there. One electron will go toward carbon side and one electron it will keep toward itself. So due to loss of one electron, it is carrying a +1 charge. This molecule, this is known as tetrahedral intermediate. Tetrahedral intermediate. Because here the hybridization of carbon is now sp3, and we know sp3 hybridized carbons make which kind of structure? Tetrahedral. It was sp2, now its hybridization is changed to sp3. This is tetrahedral intermediate. Step third. The tetrahedral intermediate which is generated over there is highly unstable. You can check instabilities here. Oxygen with a positive charge, two oxygen atoms on a single carbon, they all are instabilities. So this molecule will release out all these instabilities. How? First, this oxygen will stabilize itself by breaking bond from hydrogen. Obviously, one electron is short, that's why it have a +1 charge. So it will get that electron from hydrogen side. So when oxygen and hydrogen bond will break, this hydrogen will release out as H positive without any electron, because the electron has gone toward oxygen side. Now this is electrophile looking for electron. Again, where we have electron, any oxygen can provide electron. This oxygen, let's attack it on this oxygen. Due to which, next condition will be this. Check this oxygen. Now it got one more pair. So two pairs are there and +1 charge will finished because it has got electron from hydrogen. So it is neutral now. But this side problem will be generated. This oxygen lone pair, vacant orbital, dative bond will generate with hydrogen. And here we have only one lone pair, due to which this oxygen will become +1 charge particle. Still it is unstable. So it will start breaking bond from carbon. And obviously oxygen is more electronegative than carbon, though both electrons will shift toward oxygen. So from here what will release out? H2O, side product. And what about this carbon? Because it has lost one electron, so vacant orbital will generate. Let's draw it also. Like this, which will be satisfied by neighbor oxygen by bringing these electrons like this. Again H positive will released out, and finally what we will get? Double bond between oxygen and carbon, OR, and H positive ion will release out. So look at the products. Water molecule. Check this one. This is what? This is ester. If I will write it in a straight manner, so it will be RCOR. Now you can watch. This is ester. And what is released out here again? H positive. What this H positive will do? It will repeat all three steps again with another molecule of carboxylic acid, another molecule of alcohol. So that's why in start sulfuric acid was used in very less amount, means in catalytic amount. Because during the course of reaction, automatically H positive ions are getting generated again and again, and the three steps will be repeated again and again. So sulfuric acid we require for just start of the reaction, and after that, after onward, H positive ions are continuously getting generating from the molecules. So these are the three steps we have for esterification mechanism. Now watch carefully. One point I want to make it clear over here. Please check this tetrahedral intermediate which was generated. This one. This part was alcoholic part. Am I right? ROH was attached on carbocation, alcoholic part. And after that, what we have done? This part has released H positive ions. Means alcohol part is releasing H positive ion. That's why alcohol is working as an acid here. Not directly, like no step is showing direct release of H positive ion like this. No step is showing this release of H positive ion from alcohol directly. Am I right? But alcohol, after attaching with carbocation, it is releasing H positive ion. Means indirectly it is showing acidic behavior. Note it down. Next point. Alcohol, very important point, and carboxylic acid. If I am using alcohol CH3OH and carboxylic acid COH and alcohol CH3CH2OH and carboxylic acid CH3COOH, what is the difference? One esterification reaction I am doing with these alcohols and carboxylic acid. One esterification reaction I am performing with these alcohol and carboxylic acid. In this case, speed of esterification will be fast. And in this case, speed of esterification will be slow. Note it down very carefully. When you have alcohol with less number of carbons and carboxylic acid with less number of carbon, speed of esterification will be fast, and as you will increase the number of carbon atoms in them, speed of esterification will become slower. Reason was in second step of the mechanism. What was the second step? The second step was in which carbocation was available, and on this carbocation, alcohol molecule was attacking. This step. And after that, tetrahedral intermediate was generated. As number of carbon atoms increase, don't you think R group will increase? Alkyl part. Bigger alkyl parts, suppose the R groups are bigger. It is bigger. Due to bigger alkyl part, don't you think when they will attack, they will feel a problem of steric hindrance? Means crowding. That's it. This is the main point. Bigger alkyl parts will feel steric hindrance. That's why these two molecules can't react with each other properly with a fast rate. If R groups are small, less number of carbon atoms they have. So this problem, steric hindrance problem, will not be there, due to which these particles can react very quickly and the reaction will be very, very fast. This is the point. Very, very important point. Like if I ask, out of CH3, CH2, COOH and CH3, COOH, which will give fast reaction during esterification? What will be the answer? The carboxylic acid which have less number of carbons, means this one. And same concept is applicable on alcohols. If I ask, out of CH3, CH2OH and CH3 branching is there, this one, which alcohol will react fast in esterification? The answer will be this, because R part is small. Carbocations and alcohols can react very quickly. That's it. This is the end of mechanism of esterification. In next video, we will check reaction with acid chlorides. Thank you very much.